Yeah, this is my new company. It's just started like 4 months back, so I'm pretty new to this country. So it's called AsFigo. But today my presentation would be talking about open source verification. And I come from both user and a bit of developer experience, but I'm going to talk more and more from a user experience this side. And I want to touch upon assertions as well as unit testing, because the primary question people come up with is have this beautiful SystemVerilog test bench, but it cannot run on an open source simulator. Popularly, there are two of them. If you have been tracking it, there is AsVerilog and there is Verilator, and both have their own limitations. And the good news is Verilator has come up fairly good enough to support all of what I'm talking about today. So which is hopefully a big motivation, especially for the university and academia here, to come and use more and more. And of course, there are shortcomings. We need to enhance it. And I would openly request people to start contributing. So I will also talk about some of the open source developments that I've been doing on test bench linting, which is one area totally underserved in my honest opinion. A long back, those who have been using SpecMan probably would remember there was something called HAL or an E-analyzer for those who knew it. Fantastic. I was appreciating it, saying there were great test bench rules back then. Now, 20 years down the line, we still are struggling to lint our UVM code. So that's what I'm trying to address using this. Okay. Yeah. Okay, great. So, I'll kind of quickly skip through some of these slides, partly because this was also presented, the assertions and the unit testing, as part of another open source conference in the US 2 months back from my US colleagues. So the assertions and unit testing, there's a very great 30-minute video on YouTube. It was part of LATSUP conference, if some of you want to Google it and figure it out. But all of this content is going to be available on the web, and this is all available on the GitHub. So intention is to again show that a commercial protocol such as AMBA can be today verified using assertions and open source. Using assertions is no brainer. People have been doing it. What's different is today you can run all these assertion specifications that you see on the slide using open source simulators, which is something I feel quite happy about. What we did was we took something that was running in production and ported it to suit what the subset supported by Verilator. It's again being done by a lot of different people, the contribution. I haven't done much in terms of the implementation into Verilator, to be honest. But what me and my team have done is to take an existing AIP or an assertion IP and port it to run on Verilator and make it successful. That's what I'm sharing. So there are some specification line items that I've just highlighted, only to show that this can actually run temporal assertions in Verilator in the next couple of slides. Again, there was a good doulos training on SystemVerilog. So those who are not familiar with the syntax probably are already familiar. This slide is not a syntactic, downpour of the, the A's and B's of SVA, but rather my intention is to show that we can actually do disable FF. We can do antecedent and consequent. All this today again for free, and you already see the non-overlap implication operator, right? In again open source. You could also do the action blocks. In fact, even almost like a tick UVM error, if you want to, you can do that today in Verilator. That's the whole idea of showing this particular slide, I think, more than in terms of exact syntax. So what does it support? Again, as I mentioned, this whole thing is talked in about 30 minutes, this topic. I'm kind of rushing through a bit because I want to focus on what is new over here. So the SVA support today, the named properties are now available. It wasn't when we started this back about 3 months back, but now it's available. And then temporal assertions, yes. Verification directives, assert, cover, etc. Yes, assume. Signal value functions, yes. And then you also have default clocking block, which was a big surprise for me because, again, a lot of people who, when they write code, it becomes too much verbose. And by using these subtle things like default clocking, your assertion code can start looking beautiful, right? I strongly suggest you try it out. What is not supported is also here. Default disable is something that I want to support, but I'm not skilled enough to do it in Verilator yet, or I just don't have enough time to do it. The sequences, the temporal sequences do not work today. Again, this is something I would strictly suggest that I can't do it because it's too much into the automata and all that. Those who can do from a university background can contribute to it. That'll be fantastic to do. It's a great project. Again, quickly picking in the Google SOC, GSOC program, if you can float it, and then if some students want to apply and then support this as addition to Verilator, that would be fantastic. We're doing a similar thing. Again, I'm not doing it, but there are people doing it for SDF support in Verilog, for example. That's just a corollary. So things can happen if you all work together to make these things happen. So once the assertions, again, I'm not saying everything is honky-dory, but today you can actually write AHP, AXI, and APB, all three protocol assertions. A lot of them can be simulated using Verilator. That's the good news. Now, one is to write assertions. How do I ensure my assertion is right? This is called the verify the verifier, right? How do you verify your verifier to begin with? That's where I strongly believe unit testing can be of great use. And it's also because the unit tests give you a different way of approaching SystemVerilog class-based test benches that can today run on open source again. So this is required some work, and I personally have done some contributions. I'll list some of them. But today, the good news is on the top of the tree, if you go to GitHub, you would be able to pull it, and then run SV unit with Verilator. Those who are not familiar with the SV unit, again, there's a great gentleman named Neil Johnson who developed it, and then Tudor in Germany maintains it. So it's a pretty good approach to unit testing. So which basically gives you an idea of, we adapted to assertions. I'll go a little fast. There's a pass trace and a fail trace that we developed for each assertion. So let's just take a very quick example. I'm going to go a little fast. So this is the syntax that we have P cell, and then not a P enable. The next state shall be P enable. Nothing big deal. Now, what I'm showing you here is the unit test that actually runs again in Verilator, and it's all SystemVerilog code. You see the interface, you see the macros, you see all kinds of things that actually works today, right? So this is the unit test, just a quick example. Now, this is the suite that you can develop. In a unit test, you develop individual tests, and you put them as part of what is called a test suite, and then run through regressions. So this is what we have done. For each assertion, we developed a pass and a fail test. Again, all this code is available on the web. So these are some of our contributions. Again, each of them is really, really small, probably as simple as adding a semicolon or adding a comma support, etc. It requires that kind of commitment from all of us to make it happen in open source. So switching gears, RTL Landing, I'm sorry, there's some hiding here. I didn't notice it. Deepa pointed it to me. Thanks, Deepa, but I could not fix it on time. This particular variable image is hiding some of the text. I'll briefly talk about it. RTL Landing is very popular. People have been using a lot of tools. There are these naming guidelines, coding styles, synthesis checks, etc. Nothing new. The good thing today is you can do most of it using, again, open source tools. Verilator has a lint. Variable has a lint. Variable is from Google, for those who are not familiar with it. And then there is another Rust-based approach called svlint, I think. It's all again available on the web. You can do all of it. And you can actually, now teams are starting to use this as part of the CI/CD flows, wherein when you check into Git or Perforce and things like that, these checks can kick in and make sure your code that is checked into the system is clean, right? And that's something you can enforce it for free today. So to demonstrate this further, we took it to the LowRisk, which is again a Cambridge-based startup. Many of you are familiar with, and they just announced the RTL freeze, right, for the open patent. So what we did was we looked at the coding guidelines because RMM is old. How many of us still work on RMM, right? We still have probably the lint policy out there, reuse methodology manual for those who are familiar with it. So I'm saying LowRisk has a set of guidelines that can be enforced using multiple open source tools such as Verilator and Variable, right? Again, this is not something greatly we have done. What we have done is here, in a way, we are basically saying we are trying both the simulators, and we are also providing a flow to integrate it to CI/CD. That's something I provided as a service. And then you can also do custom policies. This is something not completely working yet with Verilator, but we are there, almost there. A matter of probably a week or so from now, we should be there. Don't count me on that, but it's that kind of effort. It's not that hard to do it. Similarly, the Variable has its own way of doing it. I don't like it too much because I'm not a C++ guy. I'm going to move to Python-based which can do a lot more and a lot easier. So essentially, it's a great potential candidate for prime time adoption. When we talk about RTL Landing today, open source can actually do it for you. I'm not claiming it's as great as some of the commercial tools with formal capabilities, etc., but we are getting to start there. This is my favorite topic. I'm going to spend a few minutes extra. And the meme is something I showed it to a few people and they started liking it, right? I don't know if the colors have come out very well, but basically what it says is always code as if the guy who ends up maintaining your code will be a violent psychopath and he knows your address. So you better be careful, right? Meaning that your code better be of some quality, especially when it comes to UVM, your sequences, your drivers, monitors. Don't just type in code. Code it in a style, right? So this is the new paradigm, I would say. The paradigm is new, but the concept has been there forever. Test-bench linting, as I mentioned, e-analyzer had it for long, right? Now, it's a proven concept, but for good or bad reasons, we don't have it today for SystemVerilog and UVM in an easy to integrate way. There are some commercial applications, commercial tools available out there, but today I would be almost safe to say many of the major vendors probably do not provide you as easy as it is, for example, RTL. So what we did is we looked at all available options, variable, SVLint, and then PySLint is what we ended up creating. This is something personally I have started contributing a lot. This is based on something called SLang. Just like for C, you have a CLang. For SystemVerilog now, there is something called SLang. Again, that's open source, not by me, but by a gentleman named Michael Poplowski in the US, I guess. And he has also added a Python binding for it, which is called a PySlang. Now, what we did was PySLint on top of it, right? So, which I will talk about some SystemVerilog rules as well as UVM linter rules that we have developed. Pretty much this is my last slide after this time done, if needed. Right? So again, what I'm trying to show you here is long we've been waiting for these things. And we had great reasons why not to do this in the commercial tools today. You ask your favorite EDA application engineer, they come up with wonderful reasons for it. Now bypass all that, you can do all that in open source, which basically I'm just giving you some hint of what these are. Again, bulk of what I'm showing you today is available on the GitHub. If you go on Google PySLint, you will find it. If not, I'll be happy to provide you a drop, right? It's already there. So some of the rules that I'm just showing you here are the naming, styling, and etc. But there are a lot more interesting ones. For example, the SVA, missing fail action block, which is one of my favorites. If you write an assertion, don't just let others debug it for you. Remember that rule saying, there is a psychopath out there. So you better do it the right way, meaning add your action blocks, add your UVM errors, etc. in the right way. And there are styles like class method shall be external. All this is now, again, it's all Python code. If it doesn't work for you, go ahead and tweak it. Please consider contributing it back. The bottom box out there is the UVM linter, which is kind of hot. I'm still working on it. It's not completely out there yet, but I have a local demo running. If anybody wants to see it, I'll be happy to show you. Again, it's going to be open source. Don't worry, it's built on the same PySLint. But some of the interesting ones, for example, the driver, missing parameters. You're supposed to override with your transaction. The request, you should override with your own data type. If you don't do it, it'll still compile, but you'll get a different error. And that error, for those who have just started with UVM, is mind-boggling, right? You're going to debug it for a long time. And this takes literally 2 seconds to run it. And then says, hey, here is what's missing. Similarly, the UVM agent, if you were to declare your own is_active field within the UVM agent, you can do it, but please make sure you set the default value to be active. Otherwise, it becomes passive, right? Again, these are really deep rules that you would start appreciating if you do it. But if somebody has done it wrongly, you don't have to worry about it. Now you can use a linter to catch it. The last one is one of my other favorite ones. Let's say you have a UVM monitor, but for some reason, there is no virtual interface in there. And again, please remember, we are not doing a grep or a find and fancy pattern matching here. We are doing a language model adoption. We are walking through the object models to figure out whether there was a data type declared or a variable declared of virtual interface type. That's pretty much what I had. The last slide is a case study from Apple. Probably many of you know him. Avidan, he is a very popular LinkedIn guy. He just puts us and say, hey, except Dave Rich, again, shout out to Dave Rich, right? Many of you know him. What's wrong with this code? Compile-wise, no problem. Now, there is a problem. You can go and read about it. The good thing is, PySLint catches it today. And again, it's available on the web. So that's my summary. Exciting new frontiers. Open source can now lead commercial tools, which is what I love about it. And UVM is a work in progress. And yeah, it's now unreal. We showed assertions, we showed unit tests, we can do RTL linting, and we can now do test with it. Thank you very much.
Thank you very much.